friends, welcome back to ErrorCode. I am Tanesh. So today in this video, we are going to have a look at my last year's project, Inflammable Gas Alarm System. So let's start.
This project is capable of providing alerts on mobile device in case of gas leakage. The application which is going to be installed in the mobile device is made with Android Studio and the hardware is created using ESP-32 as a base. So let's have a look at the hardware we need to build this project. First, ESP-32. I prefer using this over Arduino because it offers Wi-Fi and Bluetooth connectivity without much hassle, consumes less power and has more GPIOs, and moreover it is compact. Second, display SSD1306. This display has support for displaying images. It supports I2C communication protocol and consumes less power. Third, MQ2 sensor. This sensor can detect LPG, propane, methane, alcohol, and smoke. It has high sensitivity and fast response time. We also need two LEDs and a piezo buzzer, couple of wires and a breadboard. These are all the things we need to build this project. This is the circuit diagram of how it is going to be assembled. So now we can start assembling the project.
Here are the components that I am going to use. This is ESP32, MQ2 sensor, here it mentions Q2. This is SSD1306 display, buzzer, two LEDs, one resistor, and this breadboard. Next we have wires here. If you prefer, you can use these wires or these flat ones for neat and clean wiring. So I am going to use this one.
Now let's design some UI images for this. I am going to use Photopea for this purpose. Now click New Project, Set width and height to 128 by 64 pixels and background to black. Now follow me around for designing a nice title for the display. Now when the designing is finished, we need to add a threshold layer. Click on this icon and select threshold. Adjust the value according to you, like this one is good. Now take the pencil tool and reduce the size. Tweak the image according to your preferences. Like we can remove this white pixel here and this here. So now this image is looking better. Similarly, I have designed these images, one more intro image and these two images with gauge, one with full Wi-Fi icon, that means Wi-Fi is connected, and the other one with only a dot instead of the symbol. That means Wi-Fi is not there. And I have also replaced this warning icon with bell icon because it will look better on small screen. Now in the next step, we are going to set up the Firebase database and authentication. But before that, we need to save this. Go to File, Export as, then PNG. Then hit the Save button. Now let's create a project. Click Create a project. Enter the name. So let's choose this for the name. Continue. Now let's click the continue button. Once in this interface, click on build and then on authentication. Click get started. Then in sign in method, add anonymous. Enable it and save. Similarly, let's set up the RTDP. Click on create database. Choose the location and click enable. Now let's go into the rules tab and now change these to true. This will enable our device to communicate with the database. Publish the rules. Go into data. Copy this URL and save it for later. We are going to need it. Similarly, go into project settings and copy this web API key. We will need this too. Now let's understand how the communication between server, hardware and mobile device is going to be. First, the device is going to be registered by mobile phone. The device will check its EEPROM for the Wi-Fi SSID and password. If the Wi-Fi is not available, it will start a temporary server with only one route for setting the variables in the EEPROM. The user will connect to this server via Wi-Fi and set the SSID and password and some user-related details. Once this registration is done, the device will start communicating with the Firebase server, updating the sensor output. The Android app will show this value too in this gauge chart. Now, it will also create two fields in the database to control the exhaust and siren. The hardware will receive it and take actions accordingly. Moving on to the coding part, we will use Arduino IDE. Firstly, we will import all the libraries we are going to need. Now, for the images we created, we are going to search image to CPP and go to this website. Then we are going to drag and drop the files one by one. Like first, let's drag and drop intro and click generate code. So this will convert our images into bytes array. Similarly, we will convert all the images to this format and paste it in our code. Now after setting up the image arrays, we have to define some variables like where are our components. Sensor is on GPIO 35, LEDs for siren and fan are on 18 and 19, and buzzer is on 13. Next, we define the dimension of the screen, initialize the display, and we are going to calibrate the sensor before using it. That means we are going to heat up the sensor. Next, define these all variables for needle rotation logic and for server logic. Next, define the API key and database URL that we copied earlier. Some Firebase things, EEPROM size and other useful variables. Now let's start defining some functions. First, to write the strings to EEPROM, one to clear it, and one to generate device ID, that is MAC address of Wi-Fi and some random 3-digit numbers at the back. It will look something like this. A function to read data from our memory and returning it. Next, to create a web server for setup, it will take requests like this, stores the data, and then responds back with generated device ID. Another one to start the access point for setup. Next, a function to start the web server and displaying what to do on screen. Another function to test Wi-Fi connection and displaying it on the screen. As I said, we will be calibrating the sensor. We are going to define a function. This shows simple dot dot animation on screen while beeping the buzzer. Next, it displays calibrated and Wi-Fi connectivity status. And we have to define this gauge function. We display the image according to the Wi-Fi status and handle the rotation of needle according to sensor value and display it on the screen. Next, we define some functions for introduction and one to display the sensor value on the screen. So as we are going to use both the cores of ESP-32, we are going to create a task handler and add watchdog timer configuration. If we do not configure it, the device is going to restart again and again. Now define the functions for different core. First, this. It will run the setup and loop functions that we are going to define for another core. This is the setup function for second core. It reconfigures the watchdog timer, sets up the Firebase, signs up as anonymous and starts the streams for exhaust and siren. the two things we need to control. Next, this loop function resets the watchdog timer and updates sensor output on Firebase if there is any change in the value, and it controls pin 18 and 19 that are siren and exhaust according to the value in the database. Here is the main setup function. It initializes necessary things, tries to connect with Wi-Fi through data stored in the memory. If it connects successfully, it displays animation, calibrates sensor, and starts the other code, pinning it with that function we made earlier. Else, it turns on the hotspot to set up the device. Last thing we need to do is to make loop function. It maps the value of sensor from one range 0 to 4090, that's maximum analog output, to 0 to 100. Similarly, it maps needle angle according to the sensor value. It plays the buzzer when sensor value exceeds 50. And here an if statement to clear the memory when commanded through serial monitor. Now let's connect our board to the PC. After connecting the board to the PC, select this menu, select Other Board and Port. We need to search for our module, that is ESP-32 WRWMDA. This is it, and select the serial port, click on OK, and then finally upload the sketch. Now let it upload to the device. For the Android part, I made a simple UI. Added these dependencies and provided these permissions in the manifest.xml, and made the app register device and user through the mechanism we discussed earlier. We are letting the user to manually control the exhaust and siren, and if the screen is off and the app isn't in the foreground, it will play the ringtone or custom set sound as alert. As you can see this in the result. If you want me to explain the code of Android app too, comment down in the comment box. I will be making the next video on that. So that's it for today's video. Thanks for watching it till the end. Hope you liked it, so please like, share and subscribe. Meet you in the next video. Till then, bye bye.